Toolmaker's microscope, it's a very versatile instrument, and it is a very popular instrument among tool makers who are very specialized skilled operators or engineers, and they work in the tool room of any production based companies or organization. So in a tool room, basically it's a part of quality and inspection, or it works in coordination with the production and quality inspection department. They have different types of instruments and machines which are very precise and capable of doing any kind of mechanical job. So in a tool room, they have different types of instruments which are used for the precise measurement of any object or the dimensions. This tool room is a very important department of any company, and they have different types of instruments and devices for any type of measurement. So in mechanical industry, you know that mostly the measurements are of linear or angular. Sometimes they can measure some temperature or heat dissipation. They have different types of instruments of mechanical means, or which works on the principle of optics or light. So this is a very versatile instrument that is used in the tool maker's room or tool room, and it has the capability to measure any type of linear or angular dimension. This instrument uses optics to measure the dimension, and no pressure is being involved during the measurement. What does it mean? It means that in most of the mechanical instruments which are used to measure dimensions, they involve contact and application of pressure. This instrument is contactless and does not involve any pressure. And you can measure any type of dimension. You can perform very small measurements of delicate parts, which are difficult to analyze with the help of other contact-based instruments. You can measure the holes, the distance between holes in any plane, and the holes can be of micrometric size. You can perform any type of linear or angular measurements with this equipment. This microscope is very similar to the biological microscope, which you might have seen in biology or physics class. This is a very simple type of microscope which has the capability to magnify images up to 500 to 1000 times. That depends upon the type of lens used in this instrument. It has the capability to change the lenses and to change the magnification. And the only difference in this equipment is the capability of doing measurements. You can measure, you can analyze, you can magnify any object up to 500 or 1000 times. And then you can also measure the dimension of any object. It has an optical head which has all the system of optics to grab the image or magnify the image of an object. And this optical head can be moved up and down in the vertical direction. And this optical head is mounted on a vertical column. And you can move this optical head with the help of a clamping screw. This up and down movement is controlled with the help of rack and pinion arrangement. And it has a work table, or you can call it a base. At the base of this work table, there is a light or illumination source, and some auxiliary illumination sources are used or attached to the optical head to illuminate the surface. And work table or your base, it can be moved in perpendicular, horizontal directions, longitudinal and lateral. And the movement of this work table is controlled with the help of highly accurate micrometer screws. And you know how to work with a micrometer or a screw gauge. At the bottom of this table or base, there is a light source from which you illuminate the part from the bottom side. This table is made of glass, and you place your object over this glass, and then at the bottom of this table there is a illumination source. So light passes through the transparent glass and a shadow image of the outline of this workpiece or object passes through the objective of the optical head, and then you have an image which is projected on a screen. So screen, all optical system, they all are housed in a single unit of a optical head. And then this screen can also be rotated through 360-degree angle, and with the help of an eyepiece, you can analyze the image formed on the screen. And for taking linear measurements, the workpiece is placed on the table, and then you focus your microscope to grab a sharp, crisp image in the eyepiece, from which you can only develop image on the screen. There is a cross wire. It has two lines in X and Y direction, and then this cross wire can be placed at any particular location or point. And the shifting of the image is controlled with the help of micrometers fitted at the base or table of this equipment. You place your object on this work table and illuminate your light source, which is placed at the bottom. Or if you want to analyze the surface of any object, then you can illuminate the top illumination sources. And with the movement of micrometers or screw gauge, you note down the points. First, note down any reference point. With the movement of your table, you can shift your object in any particular direction, up and down and a horizontal plane. And then you measure any other point. And the difference of these 2 points will give you the dimension of any entity or element of any object. This equipment is very precise and then widely used in the development of jigs and fixtures. You know that jigs and fixtures require very high accuracy, as the jig decides the movement of your cutting tool, and fixture is used to fix the workpiece and to obtain a required level of cutting or movement. This equipment can also be used for assembly and matching of components, where the higher degree of tightness or looseness is required. This equipment is also used for measurement of tool. If you remember that mainly there are 2 types of tool wear. One is the crater wear and another is the flank wear. With the help of this equipment, you can also measure the wear which is on the cutting tool during the machining operation. As this is very precise equipment and it has the capability to magnify the image several times, this is also used in jewelry applications. Jewelry is made up of very complex design and complex features are present on the jewelry. So that complex design or any particular complex entity can be easily magnified up to 1,000 times, and then you can measure the exact dimension of that component or object. This equipment is very versatile and you don't have to fix your workpiece, as this is a contactless measuring device. No pressure is required. So you can use it to measure very thin and delicate objects. A very small amount of error or very less error is induced during the measurement of any dimension. These are the diagrams. This image is of a Toolmaker's microscope. This is a vertical column, and to it there is an optical head. This optical head has the arrangement of lens. This is the optical lens, and somewhere there is a screen on which the image grabbed through this optical lens is projected on that particular screen, and this is an eyepiece. So in this eyepiece, you can easily visualize the image forming on the screen. And this is a work table. This is a work table, and these are some buttons which are used to control the illumination of the bulb fitted at the bottom, or these are also illuminating sources which are used to illuminate the surface of any object. Means if you want to analyze the boundary or outline of any object, you have to switch on the bottom illumination source. Whereas if you want to analyze the surface of any object or any feature present on the top surface of the object, you have to illuminate these light sources, and whatever be the image or light during the reflection, it will be grabbed in this particular lens. And then if you see that here, I think it is given 2x. That means the image will be magnified 2 times. You can change the optics and you can change up to 100 times, 500 times, 1000 times. And then with the help of this magnifying lens, you can magnify the image several times. And this work table is made up of stainless steel, high grade stainless steel, and very, very fine accuracy and flatness. So this is hollow in between, and a glass plate is placed into this groove. And the movement of this work table in horizontal plane, in this X direction and in this Y direction, can be controlled with the help of this micrometer. These are the 2 micrometers, and you know what is the least count of a micrometer. You place your object here, maybe a screw thread, a screw, or any nut. You look into this eyepiece, and there is a cross wire in the form of a cross. So for any particular location, so the point which is at the zero of that cross wire, you note the reading from this micrometer. You can move that object in this direction or in this direction, and then you analyze the next point or any corresponding point present on that object, and then you measure the linear travel in this micrometer. In this way, with the difference in the readings, you can measure any dimension or entity of an object. This is schematic diagram, which gives you an idea that how this instrument works. This is the main frame of your instrument, and this is a vertical column. And with the help of this particular screw, you can control the movement in this vertical direction. You can control the movement of this optical head in vertical direction. And this is your work table. And at the bottom, there is one tilting mirror. And this is a collimating lens, which is used to get parallel light rays. And then when you keep your object here, whatever be the rays which are at the center, those light rays will be absorbed, while the rays which are allowed to pass from the boundary, they will be collected here in this optical lens. And with the series of these prisms, the light is this screen here, maybe there is some screen, and the image is projected on this screen, which can be analyzed with the help of this eyepiece. And the illumination of light source, this is for the bottom one, and this is for the top light source. The illumination of these light sources are controlled with the help of this control device. This is a knob by which you can control the illumination, any amount of brightness in this illuminating source. So this is schematic diagram of equipment. Then this is a procedure that I told you, that you keep your object. Suppose here in this case, we are taking a screw thread. We are analyzing our screw thread here. What is the profile? It was small in size, but due to the magnifying lens, the image has been magnified. You are looking into this eyepiece. This is having one cross wire. This is a very fine line inscribed in the lens of this eyepiece. These are 2 lines, X line, and this is Y line. And this is the zero of this cross wire. You analyze the image of any particular object, say a screw thread, then you can measure any element. Here, I'm interested in knowing the minor diameter of your screw thread. So with the help of this screw gauge, I will bring my object here. I will note down the point on this micrometer, and then movement in this Y in the horizontal plane. I will bring my object here, and this is going to be fixed. This particular cross wire is fixed at its location, and you can note down the another point. So this type of illumination green, with the help of this green light, you observe in the micro in this eyepiece. And in the advanced version nowadays, which is in our lab also, we have a digital Toolmaker microscope where these micrometers and this eyepiece these all have been replaced with the help of a digital camcorder. So whatever be the image which are forming on the screen, that is grabbed with the help of a digital camcorder. And then with the image processing, we process that image. There we can perform any type of measurement. So this is a simple type of Toolmaker microscope. And the advanced version is the digital Toolmaker microscope, in which we replace this eyepiece with a digital camcorder. The image can be transferred to the computer screen with the help of processing softwares. And in that software, there is a user interface which has different types of tools like making an arc, line, circle, all basic primary objects. And then with the help of software and different commands, you can measure any dimension. That is the advanced version. Suppose if you want to measure the pitch, you put the point here and then shift your object placed on the table with the help of that micrometer. You shift it to here. Basically, you move your object in this direction so that this point will come here. And you measure you note the difference in the readings. To get the angle between these two surfaces, which is the thread angle, can also be measured. For this, there is a screen tilting device. With the help of this particular knob, you can tilt the image. You can tilt the image, and then first you align your crosswire along this line. Then you move the screen with the help of this knob. This whole, can say, this eyepiece section is divided into equal number of pieces, angular division. And that measurement you can perform with the help of there is on the other side, like in this side, there is other side. And on the other side, there is a vernier scale measurement, like protector scale with vernier scale for precise measurement of angle. With the tilting of this image, you can align these two surfaces, and then with the help of difference in the angles, you can measure the angular thread angle of a screw thread. A very simple procedure and a very simple instrument which you can use to measure the dimension, any linear or any angular dimension.
So, if you like the video, then please subscribe to my channel, share it with your friends, and don't forget to hit the bell icon for the latest updates. Thanks for watching my videos.